Hi everyone, my name is Layla Kalanovich, and I will be attempting to make bread for the first time and talking about the chemical processes that occur while doing that. So baking bread is actually a pretty simple process. Essentially, there are 4 steps to it. You mix the ingredients, you knead the dough, you let it rest and let it ferment, and then you just bake it. Here I've laid out all the ingredients. You can see the cutting board, which we'll knead the dough on, the flour, water, yeast, and salt. First, we're going to add in our yeast, seen here. We're just going to drop it in there. A little bit stuck, let's tap that. And now let's add the salt right there. Also stuck, something about these cups. Just tap a little bit more. And now we add in our flour, our bread flour, pre-sifted. It's coming out, it needs to be hit again to, Now we're going to whisk all these ingredients together just to make it more homogeneous. We don't want any just packets of flour, we just kind of want it all to be mixed in well together. Now that we've mixed that sufficiently, we're going to slowly add in this cool water. And this is going to basically just create our dough. We're going to be using a rubber spatula instead of the whisk, just because you're going to see that it's going to homogenize really quickly. You can see it already getting thicker and thicker, and it's just taking on a more dough-like quality. So with the rubber spatula, we've already kind of started the process of kneading the dough, but I'm just going to take it out and knead it with my hands instead on this cutting board with some flour already on it, just to make it a little less sticky. As you can see, I'm struggling a little. This is my first time making bread. I warned you. I'm just going to keep kneading this until I feel like it's sufficiently elastic enough. So it gets less and less sticky. So what I've just demonstrated are the first 3 steps to baking bread. We mixed the ingredients, we kneaded the dough a little bit, and now we're letting it rest. Now let's talk through some of the chemical processes that were happening while we were doing it. So the main component of bread is flour. And the part of flour we care about are the proteins. Proteins such as glutenins and gliadins. These are large molecules that are built up of large numbers of amino acids and together are collectively referred to as gluten. And while gluten is initially inert on its own, as soon as you add water, these proteins are free to line up with each other and interact. They can form hydrogen bonds and disulfide crosslinks, and they form this huge gluten network throughout the dough. So now let's talk about salt. Salt adds flavor because no one likes flavorless bread. But it also does some really important chemistry. Salt can neutralize the electronically charged portions of the gluten network, which allows the coils to slide against each other faster and better and smoother. This just makes the dough more elastic, which helps it rise, which makes it better. Salt can also slow down the fermentation process. It's hygroscopic, which means it attracts moisture. And when yeast releases water during its fermentation process, the salt can absorb it, making the fermentation process go slower, meaning it doesn't happen too quickly and our dough rises at a great rate. Now, as most people probably guessed or know, the most heavy-duty chemistry occurs with yeast. Yeast has enzymes that can break down the starch in the flour into sugars and then use those sugars to create ethanol and carbon dioxide. Specifically, it has amylase. Amylase is used to break down that starch into maltose, and then it also has maltase, which can break down that maltose into glucose. The glucose is then used by the yeast, and it metabolizes it to turn into carbon dioxide and ethanol. Don't worry about the ethanol, it burns off while it's baking. Carbon dioxide, though, is more interesting. There's some debate as to how the carbon dioxide is held within the dough. The most simple explanation is that the gluten network just kind of traps it, but people are finding that it's actually a lot more complicated than that, and that there are proteins and lipids involved that help stabilize the gas bubbles as well. So to recap the ingredients really quickly, we see that flour provides the gluten, and the gluten reacts with the water to create a gluten network. Salt helps make this gluten network more elastic, and the yeast produces the carbon dioxide bubbles and give the bread that kind of volume and fluffy thing that we all love. So our second step of baking bread is kneading. Why do we need to knead? Well, essentially, kneading uncoils the gluten proteins, which make them more elastic. We love elasticity. And it can help strengthen the network of the dough. It also makes the carbon dioxide bubbles more uniform throughout the dough, so all of your dough kind of rises at the same level rather than just being like one super big bubble and like a bunch of tiny bubbles. So after letting the dough rest, you just bake it. And then after you bake it for about 20 to 25 minutes or until the crust is golden brown, you can take it out, let it rest for 5 minutes, and then slice and serve.
So as you can see, my bread is a little dense. She doesn't have a lot of volume to her. There's not a lot of bubbles. This is probably due to me not kneading enough. That's my source of error, I'm assuming.
So hopefully from this video you can see that there's A, chemistry all around us, and B, working in a kitchen is not unlike working in a lab. Gotta make sure all your glassware is clean, gotta make sure that you're clean, it requires some patience, and you end up making something completely new by the end. Unlike working in a lab, however, you have a delicious product at the end when you cook that you can eat.